What is the best way to understand clustering algorithm results? Understanding clustering algorithm results can feel overwhelming, but it doesn't have to be. Let's break it down into manageable steps that anyone can follow. First, start by looking at the cluster profiles and characteristics. This means calculating summary statistics like the mean or median for each cluster. By comparing these statistics, you can identify what makes each group unique. Next, visualization techniques are your best friends. Scatterplots are great for showing how data points group together. You can color or mark these points based on their cluster membership. This visual representation helps you see the separation between clusters clearly. Heatmaps can also be useful. They display the similarity or distance between points and cluster centers, making it easier to understand how strongly points belong to each cluster. If you want to dig deeper, consider using dimensionality reduction methods. Techniques like principal component analysis or T-distributed stochastic neighbor embedding are perfect for visualizing clusters in 2 or 3 dimensions. This is especially helpful when your original data has many features. These methods can reveal relationships and separations that are hard to spot in high-dimensional data. For a more quantitative approach, use internal validation metrics. The silhouette score is one such metric. It measures how similar an object is to its own cluster compared to others. Scores range from -1 to 1, with values close to 1 indicating well-separated clusters. Another useful method is the elbow method, which helps determine the optimal number of clusters. By plotting the within-cluster sum of squares against the number of clusters, you can find a point where adding more clusters yields diminishing returns. It's also important to understand the assumptions and limitations of the algorithms you are using. For instance, K-means clustering assumes that clusters are convex and spherical. It can be sensitive to outliers. Hierarchical clustering, on the other hand, provides a nested structure but can be computationally intensive for large datasets. Knowing these aspects helps you interpret your results more accurately. In practical applications, clustering can organize data or outputs into meaningful groups. For example, artificial intelligence tools like ChatGPT or image generation models like DALL-E and Midjourney can use clustering to enhance productivity plugins. These tools automate data categorization or content recommendations, making your work easier. Lastly, remember the ethical implications of interpreting clustering results. Clusters reflected patterns in data but do not imply causation. Misinterpretation can lead to biased decisions, especially in sensitive areas like hiring or medical diagnosis. So, to understand clustering results effectively, combine statistical summaries, visualizations, validation metrics, and knowledge of algorithm properties. Always keep in mind the ethical considerations of how you use these clusters in your applications.